Okay, we're going to talk about dynamically resizing an array. So up to this point, if we wanted to have an array, we've been forced to know what we're declaring it as right away. So if I wanted an array of strings, I'd have to say right off in the declaration that I wanted it to be a length of 4. And then along with each length, we need to have another integer variable to track what that length is. And that's okay. And if I wanted to loop through all of the elements in the array, I would do it like this. And I forgot to include my namespace for string. And that got rid of my output error for that. Alright, and as you can see, I'm getting, it loops through each element in my array, but it's empty. And if you recall, string, because it is a defined type, it will initialize that empty array to be an empty string. So before we go any further, inside my for loop, when I'm doing my display, let's initialize each value of the array to be I. So it's going to take the integer and attempt to cast it into the string. And that gives us something a little more interesting. It gives us these weird ASCII characters. But 0 is still empty, and that's because that's reserved for no values. So instead, let's do I plus 1, so we have something to work with. And I'm going to run it again. And there we go. But what we've been stuck with is that at the time we're writing the program, we have to know how long we want the array to be. And that's okay. And you know, we might have wanted to be able to say, oh, okay, I need 5 instead. So you change it in the length, and you'll change it here in the declaration. And those are the only two places that we really have to change them. And let's take it a step further and go up to 10 and run it again. And there we go. And it looks like we're running out of characters, and you'll even get that alert noise there. So we're going to keep it at 5 for now. And even then, we could be declaring it or initializing it with something a little more interesting. But I'm going to keep it at 3. And so if we need to resize the array, we have to know what we're doing when we write the code. But I think we know that that's probably pretty unrealistic, because most of the input that we get for our data when we're running our programs is either going to be coming directly from the users themselves, or it might be coming from an outside source like a database or a web service. So really, and this is what we've been kind of avoiding, is how would you dynamically either figure out the length of your array at runtime, or based on user input, resize that array to what it needs to be. And how you do that is using pointers. And up to this point, we've kind of been using pointers as sort of an alternative to maybe passing objects by reference. But that's not really what they're for. We've seen it's more for working directly with memory. And so in order to do that, instead of declaring an array like this, what we do instead is we declare a pointer to a string array. And that gives us, you know, just like we talked about, a pointer that can be assigned to point to an actual string value, or as we've seen, you can treat a pointer very much like it would be an array variable. But this is where we start doing something new. So I would say I take my pointer, and instead of setting it to be an array, like we talked about, maybe a string array or something like this, what we'll say is we're going to use the new keyword. And we're going to say new string array of 3. And what this new keyword does is this actually will go out and allocate in memory a 3-element array, and then this pointer variable gets the address of that. So we have the memory being allocated here, and we have the pointer pointing to where that is in memory. And so if I run the program now, and again we had it at 3, you will see that it acts just like it did before. And so even if we run our program, we're not interested in resizing this array at runtime, we have the ability now to use this new keyword, and it doesn't seem like much of an advantage off of the old way, except whereas before we had to hard code in the length, now we can finally use a variable for it instead. So now where I was tracking that array length before, we had to say 3 here, we had to say 3 here. We no longer have to do that. And so what that gives us is the ability now to accept that array length through user input. And now if I run this, the default value is 3, but now maybe I'll say something like 10. Try again. Let's say 20. You get to see all sorts of different characters now. And so each time what it's doing is it's taking my input here, and it is allocating an array of that length. And so you could use this in an application to say, perhaps allowing a user to enter in a sequence of numbers to figure out the average of them. And so you could have one input to say, how many numbers would you like to compute the average of? And you could loop through there, but then also you could use that to declare the length of the array in there. Also, what you could do is if the users would continue to add input, you could grow the array each time. And so what that does now is that kind of brings up another topic of resizing an existing array. And so what we have here is we have this array that we've declared, and after the for loop we've populated with all these different values. But what we want to do is we want to resize it. So maybe it was 3 in length, and we want to resize it to be 5 or 6 in length instead. And so what we could do is we could say, and use our pointer variable again, and say, okay, well, how about an array that is 5 now? But what this would do is it would point our pointer variable at a completely new array. The old one still exists, but if we don't have a pointer to it, there's really no way of recovering it. And so what we have here instead is, for all intents, a completely new array, and we lost our old values. So what you would need to do instead is you would have to define a new array, copy all the values over, and then reassociate it. And so what that would look like instead is you'd have to create a temporary pointer that would allocate new memory, copy the values over, and then reassign it. So it would look something like this. So we'd have a temporary pointer going to a new array. Have to use that new keyword, and let's say this one is going to 6. And we would do something like this. You would do it inside of a for loop, but for the intents of illustration, I would say ARR, which is our old array, 0. Sorry, I have this backwards. Temp ARR 0 equals ARR 0. Temp ARR 1 equals ARR 1, and so on and so forth. And when that is all done, you would set the old pointer to point at what is at the new pointer. And now what happens is, remember, when we're not using stars or anything else, these are really value types. So temp ARR contain the address of the new array, and ARR contains the address of the old array. And so what's really happening here is we're saying use this address now and put it here. And so what we did is we created a temporary array, copied all the values over, and then said, hey, use that new one here instead. And a lot of this kind of stuff goes on underneath or behind the scenes in a lot of different programming languages. But with C++, we really get a better visibility into what's going on. And this is something that we will cover again. I think the exercise that I'll probably go over for Wednesday is a function to actually resize an array dynamically. So what I'm going to do is I'm going to take all this code here that we've talked about, and as I usually do, I'm going to copy it over into a function so that we can keep going through some more examples. Okay, let's see what this would look like again. I'm going to have an integer that's tracking my array length. I'm going to accept that input from a user to tell me what the length is going to be. I have my array length now, so now I'm going to declare a pointer ARR equals new integer array with a length of our length. And I'm going to have a for loop that loops through all of the values. So that we can see what we have initially. I'm going to put in 10, and nothing's happening. Let's see what's going on here. Let's debug it. Array length is 10. Ah, I did it O-stream operator instead of a less than. Try that again. array length of 10. Got my breakpoint going through. Alright, I kicked myself out of that last video. F10 means something else for my screen capture. So, and I will go play, and there we go. Now, what you're seeing here is what happens when you don't initialize an integer. You're getting this negative max value on here. So one thing that's important is that when you declare an array of any type, you have to be aware of what it's going to default that initial value to. And so what we should do is, on our loop, after we create it, we should do something like this so that we are initializing that initial value. And that is a little better. At least if we don't set a value for it, then it's not quite as shocking as what we had. But let's do something a little more interesting. Let's do the square of each of these numbers. So I'm going to say I times I. And over 10. And we get something a little better than that. And so let's cover what we did. I have an integer here to track the length of the array. I'm accepting as input the array length. Then, with my pointer here, and the pointer type has to match, so it's integer and an array integer, pointer r equals a new array of integers of r length. This is dynamically allocated memory at runtime. It can be what the user input is. It could be the user input plus 10. It doesn't matter. What matters is that this is dynamic. And so what's really happening here is that, yes, we're declaring the array, but it's returning the address of that spot in memory and leaving it at this pointer. And so what we could do, like I said before, is we could take ARR and we could declare a new array. And maybe this one would be, like I had, r length plus 10 instead. But remember, as I said before, this declares a completely new space in memory. So what happens is that this is a new array, and that old array in memory is still sitting there. And the problem with this is that that old piece of memory is going to sit there until this program is closed down and that memory gets freed up. And if we're working on a limited device, maybe it's embedded hardware, maybe it's something inside of a mobile phone, we really want to be as careful with how much memory we're using all the time, because if we run out of memory, then whatever we're working on will either error out or it'll shut down. And so there's this concept of when you're done with that memory, you should delete it as well. And what this does is we're saying delete, and there's these brackets here to denote that it's going to be an array. We're going to say delete whatever memory ARR is pointing to. And what this is we call it garbage collection. So a lot of languages will have garbage collection built into them. C++ does not. And so it's important then to get into the habit that if you're going to reallocate new memory, that you free up the old stuff also. And even I'd go so far as to say, when you are done with your application, at the bottom, you should have your just delete statements to free up that memory as well. And yes, even we are working within Visual Studio and Windows, and we know that that stuff's taken care of. But what if your application doesn't shut down right, and there's still some sort of process running, and that memory's tied up? It may not get freed up until a process runs on whatever operating system you're on, or maybe when the system reboots. So you want to try and be responsible with the memory that you're using. Even though I declared the pointer and the new array here, if I do a new array, this old array, although nothing is pointing at it, will still sit there in memory until someone else comes along and frees it up. And so that's what that looks like. So we have the concept of being able to allocate memory, but now we are also responsible for deallocating the memory as well. So hopefully these two examples will give you a start on what you need to do if you want to go after the extra credit in that data structure assignment.